Good morning, Robert Scribbler. It is July 24th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, we're going to talk about a new scientific study that identifies how human-forced climate change is altering the seasons of our world. And before I get into that, I'd just like to generally talk about a concern with regards to human-caused climate change, a valid concern. And the concern is that as human-based fossil fuel burning and greenhouse gas emissions heat up the earth, it will tend to throw off the natural variability of seasonality that we have all enjoyed for such a long time, providing us with winter, spring, summer, and fall in patterns that are climate and in ways that we can predict in such a way that allows us to have stable growing seasons and general weather stability along an expected range. And the concern that changes to that cycle could generate disruptions to various aspects of our life is a real one. Now, for this particular study, a number of well-renowned atmospheric scientists studied the fingerprint of human-caused climate change on a region of our atmosphere called the troposphere. And the troposphere is the lowest region of our atmosphere, extending from the surface of the Earth out to an average of about 59,000 feet or 11 miles above the Earth's surface. And this lower layer is being heavily impacted by the added heat from human-based greenhouse gas emissions. And we've talked deeply about a number of the impacts, such as increasing atmospheric surface temperatures and various forms of extreme weather, such as drought and wildfires that are related to this warming. This particular study, however, uses satellite data to develop model-based fingerprints on changes to the troposphere that are driven by our greenhouse gas emissions and compare it to expected baseline climate in order to develop a rationale for how much and what degree of probability seasonality is being changed by human activity. I'm going to go ahead and read the introduction to this article. I'm just going to note that some of these authors are among the most highly renowned in the world when it comes to this form of study, and that the lead author is Benjamin D. Santer. So the study notes that anthropogenic climate change, a fancy word for human-caused climate change, has become clearly observable through many metrics. These include an increase in global annual temperatures, growing heat content of the oceans, and sea level rise owing to the melting of polar ice sheets and glaciers, and I'm going to add a parenthetical statement here, thermal expansion. Now, Santer et al. Report that a human-caused signal in the seasonal cycle of tropospheric temperature can also be measured. And they use satellite data and the anthropogenic fingerprint predicted by climate models to show the extent of the effects and discuss how these changes have been caused. Now, the study found that what it did is it looked at the amplitude of temperatures, the annual cycle of temperatures in the Earth's troposphere, and they compared it to what would be expected amplitude, and these amplitudes means the range. So the expected amplitude of temperatures in a normal climate where there is not a greenhouse gas forcing, and the expected and the observed amplitude of climate of tropospheric amplitude in the present climate with greenhouse gas forcing, and they compared a number of model studies to determine a human fingerprint in this cycle. What they have found is that the variance of temperature in the troposphere is increasing, and that this is fingerprinted by the models as a result of human-caused climate change. Now, the underlying rationale is that there are signals already in the seasonal cycle due to external human-caused greenhouse gas forcings, and this includes signals detectable for stratospheric ozone depletion and particulate pollution, as well as various seasonality signals, and there are also seasonality signals in the abundance of plant and animal species in various climate zones. And so these are various climate change human fingerprint related signals. And that provides a justification for this particular study, which focuses in on temperature amplitude. And what the study found is that the amplitude did increase, and that there was a high signal to noise ratio, meaning that the detectable fingerprint was very high in comparison with related natural variability noise, and that the ratio was also very high, such that the probability of these amplitude changes, these observed amplitude changes in the 38-year satellite record occurring without human-caused climate change was approximately 1 in 5 million. I'm going to go ahead and just show you the signature of amplitude signal change in the troposphere. And a lot of the amplitude signal change is occurring in the middle latitudes. One of the drivers of this is increasing land surface temperature during hemispheric summer, and this is primarily driven by both a atmospheric warming signature, but also land drying, which increases the temperatures over land during summer. And I'm going to go ahead and just read the conclusion of this pivotal study. They state that our results suggest that attribution studies with the seasonal cycle of tropospheric temperature provide powerful and novel evidence for a statistically significant human effect on Earth's climate. And so, just to simplify, the study noted that human-caused climate change is resulting in very obvious seasonal changes to the lower level of the Earth's atmosphere, and that the fingerprint is glaring. And I'm just want to add that this study is a bit of groundbreaking work, and is part of a larger signal detection effort by scientists to fingerprint the impacts of human-caused climate change on the Earth's weather and climate, and to give us a level of confidence describing how much the changes that we are seeing now are a result of the added greenhouse gases in the Earth's atmosphere. And this particular study is very high confidence, and it shows that aspects of seasonality are already changing due to the approximate 493 parts per million CO2 equivalent forcing of the greenhouse gases that we have added to the Earth's atmosphere. So this is something that we should be very concerned about, and something that we should be talking about. In essence, human-caused climate change is changing the seasons, and that affects everyone. Thank you for joining me, and I'll be chatting with you soon.